Okay, so in this video, we're going to look at just practice problems. And if you want to try them on your own before we look at the solutions, you can go ahead and do that. You can pause the video. So here's question number 1. We're going to graph and identify the parts of the ellipse. So feel free to pause the video right now to try it on your own. And if not, let's go ahead and look at the answer right now. So first thing is, there is no x plus or minus something or y plus or minus something, so we know that hk is going to be at 0, 0. We can also see that remember a is the horizontal distance, it's always the denominator of x, and so a squared is 25, so a must be 5. B squared, which is the vertical distance from the center, that's going to be 49, so B must be 7. We can see that B is bigger than A, so we know the ellipse is going to be vertical from each other. And then, because B is the biggest number, we're going to have this formula, A squared plus C squared equals B squared. We have to add up to the biggest thing. If you plug in A and B, you can find C, and so now we have the value for C. I made a note up here, if square root of 24 is just below square root of 25, so we know that C is just going to be a little less than 5. So that's going to help us plot that point. So that gives us all we need for the graph. And so the key is A is 5, B is 7, C is just a little less than 5, and we know this thing is vertical. So then when we go to graph it, then from the center at the origin, we go up and down 7 units. We go left and right 5 units. C is a little less than 5, so I went a little less than 5 units up and down for the foci. We can see that the length of the major axis, that's the biggest distance across the ellipse, is 14. The length of the minor axis, which is the shortest distance across the ellipse, that's 10. We can see the coordinates for the vertices, the coordinates for the co-vertices, and for the foci. And so there you go. So that's problem number 1. Number 2. So now we want to graph this. So again, if you want to pause it, go ahead. I'll give one little hint. So if you want to stick around for a little hint and then pause it, you can go ahead. Okay, I'm going to give the hint. So the hint is, don't forget that in the standard form of an ellipse, you have to equal 1. So that's my hint. And now if you want to pause it and try it, go ahead. And now let's go ahead and look at the solution. So here we go. So like I said, for a standard form of an ellipse, it has to equal 1. Right now it equals 24, so we're going to divide both sides by 24. And 3 over 24 is 1 over 8. 4 over 24 is 1 over 6. So now we have the standard form. And then we can see that A is going to be the square root of 8, which simplifies to 2 root 2. B is going to be the square root of 6, which doesn't simplify. Now A is bigger, so for this equation, we're going to add up to A squared, and then we can solve and find that C is the square root of 2. We can also see that still the center of this ellipse is at 0, 0. So we have everything we need. Now, when it comes time to graphing, square root of 8 is just a little less than the square root of 9. So I went just a little less than 3 units left and right. The square root of 6 is in between the square root of 4 and 9, so I went up and down something between 2 and 3 units. A little closer to 2 units, but not a whole lot. Just ballparking it. Square root of 2, that's actually a good one to know. Square root of 2 is about 1.4, so there we go. I went about 1.4 units left and right. Remember, the foci should go across the major axis, which is the longest distance across. And then we have our vertices. Here's the coordinates for the vertices. Now the vertices are horizontally aligned. The co-vertices are vertically aligned. And then we have the foci. And then we have the length of the major and the minor axis, where I just doubled. A was 2 root 2. And so you double it, you get 4 root 2. B was the square root of 6. You double it, you get 2 root 6. And one thing I want to point out is just make sure when you're doubling, like if you were going to look at A as the square root of 8, then twice as much is not going to be the square root of 16. Don't fall into that trap. So you multiply by 2, not the square root of 2. Anyway, there we go. That's all there was to example 2. Next example. Okay, it's another graphing one. So again, you want to pause it, go ahead. If you don't, here it is. All right. So one thing to notice is that 16/9 is not a squared. A squared has to be the denominator, and right now 16 is part of the numerator. So we're multiplying by 16/9. That's like dividing by the reciprocal 9/16. That tells you what a squared is. And then the same thing for b squared. B squared is not 25 over 16. You have to take the reciprocal and get 16 over 25. And then you go ahead and take the square root of both of them and you get the value for a and for b. The other thing to notice is finally we've moved the center off the origin. So we have 1, -2 for the center. All right, so now let's take a look at a and b. B is just a little bit bigger than a, so it is going to be a vertical ellipse. And because b is just a little bit bigger, then we are going to use this form of a formula where we're equaling b squared. A squared plus c squared equals b squared. I plugged in the values and I've got my value for c. So now let's just think about this for a second when we go to plot the points. Plotting 3/4 and 4/5 isn't going to be so bad. You can think about the decimals 0.75 and 0.8 if you want for approximating where to plot those points. But what about this one? What is the square root of 31 over 20? Well, the square root of 31, that's somewhere in between 5 and 6. Somewhere in between the square root of 25 and the square root of 36. So if we look at 5 over 20, that would be 1/4. So I just looked at this as a little bit bigger than 1/4 when I went to plot them. All right, so let's take a look at the graph. So here's the graph right here. And the center, remember, is at 1, -2. I'm letting every 4 squares be 1. So there's my center. And then for the vertices, because this is a vertical ellipse, I'm going up and down. So I go up 4/5 and I go down 4/5. That's taking the y-coordinate and adding 4/5 or subtracting 4/5. And so I kind of ballparked where the points would go, but then when you go ahead and calculate these, you're going to get -6/5 and -14/5 for the y-coordinates. The x-coordinates are still 1. And then we have something similar for the co-vertices. I'm going left and right a units. A was 3/4, so I'm subtracting and adding 3/4 to the x-coordinate of the center. And that's where I got my x-coordinates of 1/4 and 7/4. But the y-coordinates don't change. And then for the foci, I go ahead and add and subtract c, which is right up here, to the y-coordinate. And in this case, because you can't simplify it, it's okay to just write it like this. If they can simplify, 1 minus 3/4 simplifies and 1 plus 3/4 simplifies. You have to do that. You'll have to write your vertices separated like this. But if they don't simplify, if you can't combine these two, it's okay to write it both points combined like this with a plus or minus point, or plus or minus symbol. And then the major axis, you just double B. The length of the minor axis, you're going to double A. And there we go. There's our parts. All right, so that gives you a little bit about graphing. Let's look at writing the equation now. So, oh wait, we have one more graph, my bad. All right, so if we look at number 4, we got to graph this. So think about how you would use completing the square to change this into standard form. And if you want to pause it and try it on your own, go ahead. And if not, I'll show you how to do it. All right, so just like normally, whenever we are going to complete the square, collect the variables you're going to complete the square on together. Because x and y are both squared, we're going to complete the square on both of them. So I collected my x terms together, and I collect the y terms together. And then this 31 didn't have an x or a y, so I moved it to the other side, and now it's -31. Now the next thing is we can't complete the square unless your coefficient of the squared term is 1. So in this case, I got to factor out 9. Don't forget to factor it out from the 36 also. And then I'm leaving a gap where I would complete the square. Here I got to factor out the 4, and I also factor out the 4 from 8. And again, I'd leave a gap here. And then you fill in the gap. So take half of b and square it. Half of -4 is -2. You square it, you get +4. But remember, I'm not really adding 4. I'm adding 9 times 4, and that's where this 36 comes in. And then over here, half of 2 is 1. 1 squared is 1, but I'm not really adding 1 to the left-hand side. I'm adding 4 times 1, and that's why that's a 4. And then factor and simplify. So if we factor this, we get x minus 2 squared. We factor this quadratic, we're going to get y plus 1 squared. Combine all your like terms here, and you're going to get 9. And then the last step is you always have to have this side equal 1. So I have to divide everything by 9. 9 over 9 is 1. 4 over 9, that doesn't simplify. 9 over 9 is 1. And then I have my a squared and my b squared. Remember, over here I have to take the reciprocal. Then I have my a and b. And now I can clearly see that b is bigger than a, so I use this form of the formula, and I can find that c is √2/2. You can also see my center is at 2, -1. So now I have all the pieces I need to graph this parabola, or this ellipse. Whew. All right, so let's go down here then. The center is at 2, -1. Actually, here, I can scroll it down just enough so we can see A and B. So my center is at 2, -1. This time I'm counting every 2 squares to be 1. So go over 2, -1. There's my center. I go left and right A units. I go up and down B units. And then I go ahead and for the vertices, since this is vertical, they're going to be vertically aligned. So add and subtract b from the y coordinate. For the co-vertices, I'm going to add and subtract a from the x coordinate. And because it's a vertical ellipse, the foci, I'm going to add and subtract c from the y coordinate. And that's where I get all of these things. And then again, remember, if you're adding and subtracting can simplify, you have to write it as 2 separate points. But if it can't simplify, you can combine them together like this with a plus or minus symbol. And then double A and B to get your minor and major axis. All right, so that's graphing. Let's look at example 5. So now we're going to write the equation of an ellipse. So again, if you just want to try it on your own, go ahead. And if not, let's look at it. Okay, so you need to think about this a little bit. The big thing though, I'm just going to jump right here. Look at this equation. So the standard form. You need to find the center and you need to find A and B. Once you know those things, then you can just plug them in to find. So this is what we're going for. We're going for finding the center H and K and then finding the values of A and B. The vertices are going to be at A or B because this is the x coordinate is staying the same. It's the y coordinates changing. That means that these vertices are vertically aligned. And so that tells us that this has something to do with the value of B. And then the foci always have to do with C. So the midpoint between the vertices or the midpoint between the foci, that's going to be your center. And we can see that the midpoint is going to be at 0, 0. Now the vertices and the foci, they are vertically aligned. And so we know that B is going to be greater than A. This is a vertical ellipse. And then again, we have this equation when B is greater than A. You can plug in your value for b squared and c squared. You can find out what a squared is. And actually, notice I didn't solve for a, because all I want is the equation. We just need a squared, really, to plug in. So that was good enough. So I know the center was at 0, 0, so we just have x squared and y squared in the numerator. We found a squared over here. If b is 8, then we know b squared is 64, and there we go. We have our equation. One more example. So here's the last example. Again, if you want to just think about this one, go ahead and pause the video. And if not, here we go. So it's still about finding the center and A and B. If we take a look here, so write the equation of ellipse with the foci. Let's take a look at the foci here. The y-coordinate is staying the same. It's the x-coordinate that's changed. That means the foci are moving left and right from each other. So the foci are horizontally aligned. That means we have a horizontal ellipse. You can always plot these points too if you need to see it visually. So we know that A is greater than B. Also, that means the major axis is horizontally aligned. That means the major axis is 2A, not 2B, and that tells us that A is going to be 4. Now we know what A is. Now the midpoint of the foci is going to tell us the center. So we are not at 0, 0 anymore. Halfway in between here is the point 2, 0. And each focus is 2 units from the center. 0, 0 is 2 units away from 2, 0. And 4, 0 is 2 units away from 2, 0. So we know that C is going to be 2. Now we know what A is, we know what C is, and since A is greater than B, we have this equation right here. We can plug in our value for A, we can plug in our value for C, and we can solve for B. And again, we don't really care about B, we just care about B squared. So I didn't even bother with B. And then plug in. Our center was at 2, 0, so we have x minus 2 and y minus 0, or just y. And then we have A was 4, so 4 squared is 16, and we already know B squared is 12, and there we go. There's our equation. Okay, so that's some examples to help you get started on your homework. Have fun.